started with the 4+1 view of software architecture and also understanding what good architecture artifacts facilitate, right? So this is how you can communicate with the new members. You can communicate with stakeholders. You can verify, validate your solutions. You can explain the solution and so on to stakeholders, and also used for implementation. So there are several uses for architecture artifacts. So what is the 4+1 view of software architecture? You should know that, right? So you have 4 base views: logical, process, development, and physical, that describes the system from different viewpoints, and also a use case view which is superimposed. So this is kind of common to all the base views. Let's look at this. So 4+1 view, the use case view, which is the top view, provides understandability for the architecture. Logical view is more static design, talks about the functionality. Process view is more dynamic. So this deals with performance, scalability, and throughput. So these are the key ways. Physical view is more related to the hardware nodes and deployments. So this deals with system topologies, managing software and deploying to the nodes, delivery of units, installation. Finally, development view is static organization of the development environment that deals with downstream activities. So 4+1 view is something you should know. Then we looked at different artifacts. Okay, different artifacts talk or convey different meaning of the system. So let's start with the business context. Business context is the residing of your system in the business ecosystem. Okay, so how does your system interact with other businesses and enterprise where this software will reside? So this shows a community, like this. If it is university, obviously you're showing interactions with or connections with the other businesses within the business context. That's what it provides. System context. Again, you should know what each of these are and what it provides. Okay, so system context. This is more a high level that includes the business context, and what it documents is how the entire system interacts with external entities where the system is a black box. So what system context provides is a decomposition of business context and provides traceability to the business context information, and also shows interactions with all the external systems which are in the scope of the system. So every single entity is shown. This is an example of system context diagram. So this is your black box, which is a system, and it shows the output systems that it, all the systems that it connects with. Third one is architecture overview. Architecture overview is a very high level description of your system, and it shows your system with respect to the elements and the relationships. So this is again very, very high level. This is part of your architecture block diagrams. And then what we do is we then add more details when we come to functional architecture and operational architecture, which are later on in the process. So in architecture overview, there are different ways we can show this architecture. One way is enterprise, where we show a very high level view of all the different pieces that are part of this enterprise. We can also show a layered view of the system. We can also show it as an IT system with different nodes as part of the system. So this is again a very, very high level, and this is not going into detail because more details are provided at the functional and operational architecture steps. And the goal is to provide different solutions. So this is an example of enterprise architecture overview, which is part of this artifact. This is an example of layered architecture overview at a very high level. And then this is IT system, which shows the different nodes that includes firewall nodes, the various server nodes, proxy nodes, then browser nodes, etc. Then we start elaborating the architecture artifact in functional architecture. In functional architecture, we're going to add more details about the system that includes subsystems we're going to include more detail that includes components as well as the interfaces. So all this we're going to start including as part of functional architecture, and this is developed iteratively through different stages of this process. So in functional architecture, we have 3 levels. So we start with high level, which is logical level. This is when we're going to start defining what the subsystems are as part of our system. Specification level is what we're going to provide details to each subsystem in terms of their components, in terms of their interfaces. And then the physical level is when we will start defining more on the hardware side, how we're going to deploy the software and managing the deployment to units of delivery. So the function architecture is a 3-step process from highest to lowest levels of abstraction. So let's start with logical level. So in logical level, we're going to take our system, which is the high level system, and break it into various subsystems, and each subsystem is then consisting of components. You can see this subsystem design. You take your domain, you take your system, and then each subsystem obviously has its own software component, so that you are going to localize the changes, which is what one of the goals are of our software architecture, right? Then we're going to provide interfaces at each subsystem level, so we can provide some interfaces for the various functionality, and then each component within subsystems will implement these interfaces to provide this exposition or exposing the IT functions, right? So this can enhance parallel development, and that's why this is done in this fashion. And this is also the human representation. We're going to look at it, but you've already seen this before. So this is each subsystem. We're going to provide details for the system that includes ID, names, functionality, interfaces, and so on. So this is more elaborate. We're going to provide dependencies of the subsystem, so we know exactly interactions between each subsystem. This is another template. This is a textual template with the details. And then the second piece is components. So for each subsystem, you're going to identify the high-level software components, and then these components will realize the interfaces exposed by each subsystem. Right? So this is more drilling down into more details. So collaboration diagram obviously shows how these components interact with each other. The component diagram or component interaction using a sequence diagram. And second is specification level. In specification level, we add details to the logical level design. So now we're going to define the interfaces. We're going to go down all the way to the data level. We're going to go through each component and then assign it responsibilities. So there are different steps in your specification level design. Okay. So what are these? We are going to assign responsibilities for a component, for each component using this matrix called component responsibility matrix. You see on the next slide. This is a component responsibility matrix using a textual format. You can see the component ID, the name, the responsibilities, and what subsystem each component belongs to. This is another representation. This is called cross-reference table that you can use in your projects as well. Each component, what is the functionality and the responsibilities for the component for functional, on the functional requirement side and the non-functional requirement side and the business requirement. And then this is your interface design. So for each subsystem, for each component, what kinds of interfaces will this component realize, and what operations are part of this interface is now part of the specification level. And then this shows interface dependencies between subsystems, right? Within each subsystem, you have components, and each component will then realize those interfaces. Finally, associating data. So we go through the list of all the components, all the subsystems, and all the interfaces we have already identified, and for each of them we need to analyze and map to a logical data map, right? So for the interfaces, for each component, or each subsystem, as part of your overall system, you need to map this data. This is another example of component interaction by seeing the messages in the human audio. Finally, physical level. Physical level is mapping to the we've started with logical level, we've gone to specification level, lastly physical level. We talk in terms of operations, right? How do we take these subsystems and assign them to hardware? So this is the infrastructure that we need to design. So this is physical level design is deploying to nodes, which are hardware nodes. The operations architecture is also more detailed, so this is more in terms of the hardware support and the computer systems. So this talks about performance, scalability, fault tolerance, etc. So this is something we will develop so that this will scale well to different, from the software to the hardware. Last one is architecture decisions. So in chapter 4 we covered lots of architecture decisions, and then some of them are shown here. We're going to take those architecture decisions, and this is a template where we can put all the decisions in and then provide justification for each of the decisions that we are going to implement as part of our architecture. So this is documentation. We went through this in class. They have all the drivers that are driving this decision. What is our approach as an architect? What are the pros? What are the cons? And then any kinds of issues and so on. And we conclude giving a justification for why this approach was selected. So this is something that we can justify even when we are conducting structured meetings like ETAM. Okay, this is something we can use, I'm sure. These are all artifacts, and then we started chapter 18 with this preface. And again, you all know why documentation is needed. Now this slide shows you the uses of the documentation. Why do we actually need documentation? Because we need to start with this so that we can define and design our architectures. And it shows it's prescriptive, descriptive, it describes what is true, it also describes what is true, and essentially it needs to meet the stakeholder requirements and make sure the stakeholders understand your documentation. It shows here what are the users, education, analysis, and so on. So choosing a notation, right? What are the trade-offs? You can choose formal notation, but that is more time intensive. But for simpler projects, you can choose informal notation, especially if you know that it's not worth it. Okay. So each document that you choose, each artifact that you choose, you should know why you're choosing it and what the pros are, what the cons are. We already covered views in chapter 2, so this is a representation of the structures of the system. So again, which views, right? So the ones we need to actually implement the cost benefit. We need to provide some kind of cost benefit analysis, and then we want to make sure that the cost that we're investing in is going to provide some kind of benefit. Only then we're going to show that we. So what are the steps for choosing views? First is we build a stakeholder view table. So this is something you can use in your projects as well. So in the rows, you can list all your stakeholders. In the columns, you can write down all the views, and then you can fill each cell, and then you can see which one are being used, which one is detailed, which one is not used, and so on. That gives you a high-level view. Then we remove any kind of marginal views. We reduce the number. Step 3 is prioritizing and staging. So in this, we want to make sure that we're going to prioritize the views so that we can include them in the documentation, knowing very well that 80% of the information that we actually want to show in the artifacts is something that goes a long way. Okay, we're not looking at perfection, we're only looking at good enough. We want to make sure that the project moves along. And then the DFS approach is best. That means we start with high-level views with the table, lots of views, and then we can drill down to each only as needed. So then documenting behavior, this is the second piece of it. Documenting behavior, we need to add this, but this is what shows performance. This is capturing all the other QAs that maybe our structure will not catch or show. So notations for documenting behavior, the so-called trace-oriented languages. So these traces are activities, they are interactions that will show how the system interacts with stimuli and so on. It also shows state information. So this is what we use to describe behavior, right? And these are some of the examples: use case diagram, sequence diagram, and so on that we use to show behavior. That's what we capture. Use case diagram, we saw this in human modeling tutorial as well. It shows the interaction of actors with the system, and then it captures the interactions, and it shows a key for the system, so it shows what this is about. And it also has a use case description, which highlights what this use case is talking about. Sequence diagram is the sequence in which the messages interact between the various components of the system along with the user, right? So it shows the flow of messages in the system, and it also shows the kinds of messages, whether it's synchronous, asynchronous, return messages, and so on. Anything that you see vertical is the lifeline of that message. Anything you see along horizontal axis is time, so that shows you along time the sequence of the messages that is being sent to each component. Communication diagram shows a chronological ordering of the messages. As you can see, there's an order, so there are numbers. So when you read the communication diagram, you know exactly in what order, what component or what part of the system generated the messages, how it went through the system, and in this case, how a three-way call is done in a phone call. Okay, so you have terminal 1, terminal 2 connection, terminal 3 connection, and then how it creates a call between different terminals. Activity diagram shows workflows, and what this shows you is the way, the order in which the actions happen in the system, and it goes through the flow of these actions, and it has various notations, and the key shows you the notations that include the initial or the start point of this workflow, the end point of the workflow. It shows you the different pieces of the workflow through these actions, right? And it clearly shows you the flow. It shows you merge node, it shows you fork nodes, which are decision nodes, and then it shows parallelism. In some cases, it does not synchronize, and so on. So there are different ways you can show the actions, and this will then give you an idea of how the actions flow through your system. Okay, so this is called activity diagram. This is a human diagram. So again, quality attributes is something we saw in the next module as well. Quality attributes show up in documentation, and that's why we are investing our time and effort to document. It's because it shows us the rationale behind our decisions. When you document it, it also shows your trade-offs. It shows more technicality because you are the expert, and only someone who knows that language, as it says, can write this. And the quality requirements are well studied and well documented, so that stakeholders who read this document knows what you're doing. What is involved. This was actually a class on activity. So this ends module 6. So module 6 talks about documentation, various artifacts. You should know all these artifacts that are covered. Module 7, we moved on to chapter 21. This concept is that of architecture analysis. When we come up with an architecture for a system, we need to provide some means of incorporating analysis, because that is what tells us whether the decisions that are incorporated part of the architecture is correct or not. Okay? So how much analysis? Obviously, you have to do a cost-benefit analysis and make sure that this analysis is, the benefits will outweigh the costs. And why do you want to perform analysis? 3 or 4 things. Okay, the first thing is risks. We discover risks. We discover sensitivity points. We discover trade-offs. And the risks, sensitivity points, trade-offs, all these concepts are in the light of quality attributes, so keep that in mind. We always talk in terms of quality attributes. So there are three forms of evaluation. The first one is designer, that is ourselves. We go through the design process and then we probe our decisions, and then we will use something called like a thought experiment. We will verbally work through a scenario, we write down the scenarios and make sure that the design process that we are including as part of the architecture is correct. Second is peers. We're going to involve peers who are our colleagues, our friends, and then we want to make sure that we run our architecture decisions through another pair of eyes, so it's correct. Third one is more expensive. We can get outsiders, either outside the organization or outside our department, who are tech savvy, and make sure that they go through the architecture and make sure that all the decisions are correct. Again, designer is yourself. We go through this, test our choices. And this is good enough as opposed to perfect. We stop when we think it's okay. Peer review. Again, you allocate several hours, half a day maybe, and then what you do is you share your design with other architects, other developers, someone who can review and make sure that you capture any problems as part of the decisions. Analysis by outsiders, again, this is the most effective because when you talk about outsiders, typically from third-party contractors, these are the experts, domain specialists. They have seen architectures before, so you're going to implement you're going to run your architecture decisions through these outsiders, and these people typically tend to be unbiased, and